Let's look at lesson 6.5. In lesson 6.5, we're dealing with linear inequalities. Up to this point, we've had linear equalities. We graph it and a linear inequality in two variables. We are going to use some real-world examples. And if you think about this, you're buying movies and video games at the store, and you can spend at most $20. What are the possible combinations of movies and videos you can buy? I'm sure you could come up with, oh, what if I only buy one movie and one game? That would work. And what we want to try and look at is what is an equation that we could use. We're going to be thinking about this in standard form, if you would. So if we're thinking about this, we kind of could say, okay, it's $2 for a movie, plus it's $5 for a video game, and this has to be at most, which means can we have $20? No. At most is less or equal to our 20. So let's think of some situations. What if I had one game? If I had one game, that means it's 2 times the movie plus $5 a game, so 5 has to be less or equal to 20. Well, 2m, when we subtract 5 from both sides, will be less or equal to 15. And when we divide by 2, if we are talking about the number of movies we could get, m would be less or equal to 7.5. So, what is the maximum number of videos that we could get, or movies in this case? The maximum amount that we could get is going to be 7 videos. If I bought 2 videos, what if you bought 2 videos? What's the maximum number of games that we could have? Well, our videos cost $2 each, so 2 times 2, plus our game, which was $5 each per game, and that's going to be less or equal to 20. Now again, 2 times 2 is 4, so 5g is going to be less or equal to 16 when we subtract 4, and we divide by 5, and the number of games we can have is going to be less or equal to, in this case, we have 3 and 1/5, so we would say 3 games. What expression gives us the total number of games and videos? That would be our $2 for a video plus $5 for a game is less or equal to 20. Do we have to buy a maximum number of games? No. And what's the least number of games you could buy? Well, what if we didn't want any games? We could possibly have 0. On your vocab sheet, you should fill in linear inequality is formed by replacing the equal sign of a linear equation with an inequality symbol. An example you could put down, y is less than 2x plus 1. Y is greater or equal to x. Y is greater than 4. X is less than negative 2.5 are all linear inequalities. The solution is an ordered pair that makes the inequality true. 2, 0 would make our first inequality true, as you are looking at those. A linear inequality in 2 variables has an infinite number of solutions. There are infinitely many solutions when we talk about a linear inequality. It is our number of solutions, and they continue on and on. We show this by shading. So, if we want to just look, is negative 2, 3 a solution to each of these inequalities? Remember, x and y. So if we are replacing those, we are going to replace y with 3. Is that less than negative 2 plus 9? No, it is not a solution. What I want you to do is to check the next 2, pause the video, and come back to the video. In the next one, we have 2 times a negative 2. Is that less than 3 minus 4? 3 minus 4 gives us a negative 1. Negative 4 is less. That one is true. Make sure you check the last one for class tomorrow. As you look at linear inequalities, one side of the line will have the solutions. The other side of the line will have no solutions. So when we think about this part has no solution, over here in our shaded part is our solution. Shaded is where the solution is. Over here, where it's not shaded, is not our solution. Dashed line means that the line is not part of our solution set. A solid line, like in the second example, means that the line is part of the solution. So when we think about this next part down here, and we are looking at this, it says each point on in this case, we're looking at it being a dotted line, is not a solution. The dashed line is used for, if we're thinking about that, we've just used it for greater than and for less than. Here, each point on the solid line, because we have a solid line, is a solution. The solid line is used for greater or equal, lesser equal. Make sure you have that in your notes. Well, let's take a look at this problem. When you look at an example and it asks you to graph the inequality, the first step is think of graphing y equals mx plus b. Next thing you have to decide, is it dashed or solid? Because in this case we have a greater than, we want to have a dashed line because it is not part of our solution. When we read that y is greater, that means above. Greater is always going to be above the line. Less is below. And we'll kind of look at some examples in just a minute here. If we are graphing this, our y-intercept, -2. Our slope in this equation, if we are looking at our equation, our slope was 1 in front of the x. So that means up 1 and over 1. So we're going to put our points. Once we get a few points, we can put them in both directions. And we said this was going to be a dashed line. It does continue on forever. So when you draw these, I'm going to have you cover your graph paper, or at least a good area of that. Where is everything above? Everything above is where we would shade. Now, what you always want to do at this point, you notice I put in your note, fourth thing you want to do is pick a checkpoint. So if we want to pick a checkpoint, if it's possible, the easiest checkpoint to choose is always 0, 0. Sometimes it's not part of our solution. In this case, is 0, 0 part of our solution? We think so. 0, 0 is here. So we want to check it. In our original equation, y is greater than x minus 2. Is 0 greater than 0 minus 2? Is 0 greater than -2? Yes. So we shaded in the right spot. Now let's practice a few more. Remember, first step, graph y equals mx plus b. What you're always looking for is your start point. When we think of our start point, that's our 0b. Then we are using our slope. And remember, slope is always rise over run. So it's really going to bring everything together for this chapter at this point. As we take a look at the first one, I'm going to do number 1, and then I'm going to let you do 2 and 3, and we'll check those tomorrow in class. As we start number 1, my y-intercept is -2. My slope, remember, can always be written as a fraction, 2 over 1. So if I continue with my slope, it should be a dashed line because it is not an equal. And we read this as y is less. Less is below the line. So what do you mean below? Anytime we're looking at below the line. Now in this case, we think 0, 0 is not a solution. So what we really want to do is maybe pick another point that we know is a solution. Well, an easy point would possibly be way over here. This point is located at 6, 0. We think 6, 0 should be a solution. If I plug that into my original equation, is 0 less than 2 times 6 minus 2? 12 minus 2 is 10, and 0 is less than 10, so we shaded in the right spot. Remember to show me, write down, pick your checkpoint so I can see tomorrow in class that you actually picked a checkpoint to see if it works after you graph. Some of these sometimes get a little harder, but I want you to think about, what do we know about x greater than any number? If it's x in a number and there's only one variable, x, top part is v, is always vertical. Y is horizontal. Now, in questions 3 and 4, when we go to graph those, we need to rewrite it in slope-intercept form. So if I was going to rewrite number 3 in slope-intercept form, I would have 4y is greater or equal to negative 2x minus 8. My next step is I need to divide everything by 4 because I can't graph it easily unless I have it in slope-intercept form. Y is greater or equal to negative 1/2 x minus 2. So if we are graphing these, let's look at the first one. X is greater than 2. If x is greater than 2, I need to go on my x-axis to 2. Remember, every point has to be 2, so we're looking at every point on this vertical line. And it actually has to be greater, which means we're going to have a dashed line. Where is everything greater than 2 on x? Well, here x is 1, so greater has to be to the right. So a lot of times we've said greater is above. This time it is to the right when we look at that. As you are taking a look at y is less than negative 4. Again, we know it's horizontal. We're going to go down to 0, negative 4. And in this case, all of these points along here is where y is less than negative 4. We're going to have it being dashed, and less in this case means below. Please try and graph number 3 and 4 so we can look at those and talk about them with your shoulder partners tomorrow in class. At this point, we want to look at a real-life example. The real-life example is this. You're going to a party, and you're going to spend no more than $12 on nuts. We're going to say that we have X as our peanuts, and Y is our cashews. I love cashews. Way better than peanuts. What does spend no more than? That means we're going to have less or equal to our $12. So our inequality is, well, peanuts are 2x plus cashews, always a little more expensive. 4y is less or equal to, and in this case, 12. Now, could you use standard form and use your x and y intercepts? You could, but a lot of times slope-intercept is a much quicker way to graph. 4y is still less or equal to negative 2x plus 12, and we divide everything by 4, and our new equation is y has to be less or equal to negative 1/2 x plus 3. We're going to graph this. On your workbook or in your notes, you have a graph. Make sure you've labeled where your cashews are. Cashews are our y. Peanuts are x. And if we're thinking about this, what we want to take a look at is what's the most number of, if we're thinking about this, of cashews that we can have. Well, if x is 0, the most y we can have cashews is going to be 3. So our top point here is going to be at 0, 3 of cashews. Well, what's the most peanuts we can have? We can have 6, 0. And if we are thinking about this realistically, this should be anywhere along this line and less than, which means we are looking at this for our solution. It is all of these points for the number of pounds that we could have. When we look at a graph, if we're going to try to write an equation, first thing, try and pick out your y-intercept. Remember, this is the easiest equation to write looking at a graph. So y-intercept here is 1. Our slope, well, I can't go up 1 and over. I can't tell if that's a fourth or a half. So I go up 1 and up 2 and over 1. So my slope, y, equals 2 over 1x plus 1. But now I have to write it as an inequality. Since it's a solid line, I'm going to have an equal, less or equal to 2x plus 1. Please try this last example, and you got it, and we'll look at it tomorrow in class.